Welcome to Algebra 2, Unit 9, Section 1, Normal Distribution. So we're going to be working with representing distribution with appropriate data plots, and in interpreting the shape of the distribution, relate the shape to measures of center and spread. Okay, so the sport of baseball has a long history of not only keeping statistics but analyzing them. One of the most common statistics used is the batting average. So batting average is defined as the number of hits a player achieves divided by the number of at-bats that the player needed to achieve those hits. So our first problem here is a local recreational baseball club, the Cobras, has 12 players. The batting average for those players are as follows: 0.265, 0.270, etc. We can go through this list right here. And what we're going to do to start is to create a dot plot. So this is pretty simple. Basically what we do is we take and just begin posting dots at those values. So at 0.265 I'm going to put a dot right here. 0.270, there's one dot for that. 0.275, there's one value there. 0.280, we have three of these, so there's going to be three dots. And there's four values at 0.285, so we're going to put those there. And then we have two values at 0.290. So secondly, we're going to describe the shape of this dot plot. Well, you can see here we're kind of starting here, and then we come up this, right? And then we come down here this way, and we would say this drops off like so, right down to 0. So it doesn't look like a regular bell curve. A regular bell curve is in this shape here. It looks like a bell, right? So what we have here is somewhat similar to a bell curve. So we are going to state that this is similar to a bell curve, but it's a little off, right? So I don't want to go with red. Let's go black. Here we go. And it appears to be skewed to the right. So now it says to find the mean and the median of the data set and find which is larger. So first of all, the mean, that's just another way of saying the average. The median is the middle value in a list of values. Right, so it's the middle value in the list. So we're going to use our calculator now, and we're going to put these values in. And basically we could just come down this list here. So you turn on your calculator. Now, since we're going to be doing stat work, this is the stat button, and we want to edit. And you'll see here I've got data up in here. So what I'm going to do is I'm going to clear all this data out. You just go up and you hit clear, and it clears everything out of there. Okay. Now we can just start entering. So we have one value at 0.265. And we have one at 0.270. and then one at 0.275. And we have 3 at 0.28. So I'm going to put in 1, 2, 3. Then 4 of them at 0.248, 4 of them at 0.285. And then 2 at 0.29. And we're done. Okay, so let's come back over here and we're going to find the mean. Okay, so we take our calculator again and we want to get out of this list. So I'm just going to go hit second and quit, and I'm now back at the main page. So now we're going to do our stat. So click on stat and we're going to do, nope, excuse me, wrong thing. We want to go to list, second stat. We want to, so we're going to do some work with these lists, and so I'm going to do some math, and I'm going to do number 3, the mean. So I hit mean. Now this was list number 1, so we hit second, and you'll see it here in blue, L1. You just hit the number 1, and that's what goes in the calculator there. So it's basically telling the calculator, find the mean in list 1. So we hit enter, and there it is, 0.2808. So we're going to say this is equal to 0.281. Okay, so the median now, we go through somewhat the same process. We're going to hit second stat, which is our list, and we're going to hit go to the right and do math, and now we go to number 4, which is the median, and this is going to calculate this from second 1, which gives us list 1, and that comes up to 0.2825. all right, so what's the shape? What's the connection between the shape of the distribution and the location of the mean and median? Well, you can see here that the mean is to the left of the median, so it's going to be skewed to the right. So what this does, so if the mean is less than the median, that means we're skewed right. If the mean is greater than the median, it's going to be skewed left. And if they're equal, well, that means you've got a nice bell curve. Pretty much a perfect bell curve. Okay, so another local baseball club, the Manatees, also has 12 players. The batting averages are as follows. And so we're going to plot this one. So I have 2 at 0.275. I have 1, 2, 3, 4 at 0.280. I have 3 at 0.285. I have 1 at 0.290, 1 at 0.295, and 1 at 0.305. Okay, so what kind of shape do we have? Well, I'm coming from here, and I'm like this. Right? So I would say we're skewed left. So we're going to plug these values in so we can find the mean and median very easily. So let's go ahead and do that. So stat, edit. I want to be in list 2. So I want to keep my old data. I may want to compare some stuff. So I have 2 at 0.275, 2 values of 0.275. I have 3 at 0.280. Oh, I have 4 at 0.280. Right? Do I have 4 here? 1, 2, 3, 4. Okay. I have 3 at 0.285. I have 1 at 0.29. 1 at 0.295. And then 1 finally at 0.305. Alright, so let's see what this looks like now. Okay, so let's take this up here, find the mean and the median. So we quit this. Let's find the mean. So second list, go to math, and there's the mean. And we're in list 2 here, so second, number 2. So that's 0.2845. We're going to round this to the nearest thousand, so we're going to go 0.285. So the mean equals 0.285. The median, let's do that. And that's 0.2825. Alright, so the median is to the left of the mean, right? So this is skewed left, right? Alright, so if we compare and contrast, right, these two shapes, this one's to the left, right? This one's to the right. Okay. Oh, so we should have written those down. Oh, look at this. I've got the in the wrong spot. So let's correct that. And this mean was the larger. Right? Okay. Okay, so what's the connection between the shape of the distribution, location of the mean and median? Well, we already discussed that, right? So compare and contrast the shapes of these distributions. All right. So if you look at the picture back here, we have this outlier, right? This guy is a difference maker right here. His batting average, right, is considerably higher than the average. Okay. So he's a full 20 points higher than the mean average, right? Than the average for the entire team. If we look here at the other data, right? This person here is your underperformer, right? And if you look at the difference between that outperformance and the lower one, okay, you can see here he's 40 points. We'd call 40 basis points under the other team's best player. And he's 25 under his best team's player. Okay. All right, standard deviation now. So standard deviation measures the amount of variance between areas. If we were to come over here and just kind of take a look here, and let's just build a standardized kind of bell curve of, let's say, height, average height, right? And if we look that most people, you've got some very short people here, right? And then you have some exceptionally strong tall people over here, you know, your NBA basketball players, right? 6'7" 7'3", 7'2", right? Exceptionally super tall people, right? But inside here, right, you've got the bulk of humanity falls into this area here with their average height. Okay? And then you have some shorter people and some people you would just call tall. But the bulk of the people, the greatest number of people are going to fall in this area. Well, this value, standard deviation, measures how much variance there is from one end of the spectrum to the other. So, in looking at these two teams, right, what are the standard deviations? So, again, we'll take our calculator out, and it's a real simple measurement. We just go back to the list, right, and we're going to go to number 7, standard deviation. And we're going to use list 1, right? And that's the cobras. And so the cobras are from 0.007, right? All right, that's their standard deviation. The manatees, what's theirs? Well, we can go back to our calculator and again pull up our stat of standard deviation, and this is for the values in list 2, and that comes up as almost 0.9, right? We would round that up to 9. So what this measures is the amount of variance in the overall list, right? The amount of difference in performance. All right. So What did these measure? The differences in performance. So in looking at these lineups, the Cobra's lineups has a much more condensed and or homogenized level of performance than the Manatees do. So now if we take a look at some other teams in these type of graphs, now these are histograms, okay? So basically all you're doing with this is that there's everybody here, there are two values of each on the turtles, right? This one's got 1 here, there's 4 here at this value, 4 at this value, 1 down here, 4 up here, 4 up here, 1 down here. Okay. If we were to look at the graphs here, well, we would say this comes like this, right? It's rather wide and fat. This graph comes up here and comes down and then comes back up, and it looks very similar to some of the polynomial graphs we saw, but there seems like there's two towers, right? The graph for the snappers here is, right, so we've got 1 here, 2, 3, 3, 3, 2, 1. So we're coming up here, and this I think would look more like a traditional bell curve. All right. All right. So we've got the first one was the, I remember correctly, the turtles, cottonmouths, and snappers. So the turtles look like a box, right? The cottonmouths was what we called the two towers. And the snappers were the bell curve. Okay, now we want to find the mean and median for each of those distributions. Okay. So let's go ahead and look at these, and we'll just put them in. So we're going to put this under all right. So let's go back to our handout here, and it says let's find the mean and median. Okay, so we've got the turtles, cottonmouths, and then the snappers. And we'll build a little chart here. Here's the mean column. Here's the median. Right? So the turtles, let's do that one first. So let's just clear all that out. So for the turtles, the mean, that's list 3, was 0.28. The median this is L3, right? Okay. And that's also 0.280, right? And that's the boxy looking graph, the histogram. The cottonmouths with their 2 towers, what do they look like? Well, let's go check it out. .285625. So let's just make it 0.286. 0.286 is the mean. The median for list 4 is going to be 0.29. And then our final group, which is our bell curve, snappers, mean of list 5, 0.2829, so we'll say 0.283. And our median and that's 0.285. Okay, so let's discuss before we move down, or let's go ahead and move on down with this. If a distribution follows a well-defined pattern, a smooth curve can be drawn to represent the distribution. All right, so guess which teams of distribution of batting averages has the largest standard deviation? Guess which one has the smallest? Use your calculator to find the actual standard deviations and confirm and or revise your conjectures. So if we go back up to the original graphs, right? So we might look at this graph here and see that the curve here is very flat, right? This curve here comes up here and it comes back down and it comes back up and it comes back down. All right, and then this last one we have a nice bell curve look, right? So it would go probably to take a look right here and see what the differences is. So this has 0 difference, right, between their mean and their median. This one from mean to median is 0.004, and this one is 0.0 0.002. So we might look at this and say, well, the cottonmouths have the greatest difference between their mean and median. So does this mean their distribution has the largest standard deviation? All right? So we might take a look at this and say, okay, the cottonmouths, right? So let's say largest is cottonmouths, right? And the smallest would maybe be the turtles, right? So this would be the largest, right? And the turtles you might think, well, the turtles, there was no real change. So that would be the smallest change. So let's take a look at the calculations. So if we go back to our list, we go to the math, we can go to standard deviation. So we're going to go to the standard deviation of the turtles, which was list 3, and that comes out to 0.013. Right? So let's go and make our list here. Alright, so turtles, I'm just going to put CM for cottonmouths, and then snappers, we'll just put snap. Right? And we'll make column standard deviation. So again, this is 0.03, 0.0103. Okay. And then our standard deviation for our cottonmouths, which was list 4, comes out to 0.01. And this should actually be 0.04 now that I look at that, because I didn't round correctly. So we're going to make that 0.0104. And cottonmouths, 0.0101. Right? And then the snapping turtles, or the snappers, again, come over here, take our, oh, I don't want that. Let's try again. List, ops, math, and we're looking for 7, standard deviation, and this would be with list number 5, and that comes out to be 0.0096. So clearly, the biggest standard deviation came with the least volatile graph. So the turtles had the largest, and the smallest was with the snappers. Okay? So the greatest divergence of scoring comes with the turtles. Okay, so below are each of the distributions we saw in items 1 through 7. For each distribution, draw a smooth curve on this. So we've kind of been doing this all along, but here is our distribution. Right? And we would say this here. Right? This tail here comes here. Right? The turtles oh, that's ugly. Let's try that again. Oh, oh. And then cottons. For those of you that do not know, a cottonmouth is a very large snake, lives in swamps, very aggressive and very poisonous. And then last is a pretty nice looking bell curve here. Okay, so each of the curves drawn is called a density curve, and these density curves have special characteristics, right? They're always drawn above the x-axis. Okay. And the area between the density curve and the x-axis is always 1. Okay, so on the Cobras, a player with the batting average of 0.270 was Walter. One player with a batting average of 0.290 was Leslie. The coach wants to know how each player compares to the mean batting average. From your previous work, you discovered that the mean batting average for the Cobras was 0.2808 and that the standard deviation was 0.0076. So the coach does these calculations, okay, basically taking Walter's batting average. So here's Walter's average, and subtracting it from the mean and then dividing it by the standard deviation, and they got this score right here of negative 1.421. And Leslie, okay, so this Leslie is here, all right, and subtracting her, taking her value, subtracting the mean, and dividing by the standard deviation, they get a score. So taking a look at this, all right, what do you think these calculations represent? Take a moment. Okay, well, one of the things we're doing here is we're saying Walter is underperforming Leslie, right? We can compare an apple, it's a statistical comparison, all right? So this is just a statistical comparison of performance. Okay. So Walter is apparently underperforming the average, and Leslie is outperforming the average. All right. And these are called z-scores. All right. So we can compare to a mean. All right. So the z-score. So the positive or negative. Negative means underperforming. And plus means outperforming. No. Cut it out. Okay. Okay. So going forward, the rest of these questions you're on your own. 11 through 12 and 13. Okay? And 14. And 15. Okay, so go ahead and practice with those. Actually, we'll cut there. We'll look through this. Actually, let's do this one. So the grades on a quiz for 3 of Mr. Dean's classes were analyzed by finding the mean, standard deviation, shape of the distribution for each class. Mr. Dean dropped his papers doing this analysis, and the shapes of the distributions were separated from the means and medians. Which shape belongs to which mean and median? So a mean of 70 and a median of 70. Well, that's pretty easy. That's going to be right here. Okay. Mean of 70, median of 60. And that's going to be here. And then this one is C. The mean is 70, but the median is 80. Okay? So we talked about those skewed values. Okay, so the mean length of a python is 2 meters with a standard deviation of 0.3. The mean weight of the same species of python is 25 kilograms with a standard deviation of 5.4 kilograms. A 2.7 meter python weighing 30 kilograms is captured in a state park. Use the z-scores to determine which characteristic of the state is more unusual, its length or its width. Okay, so we're going to take the length of 2 meters, all right? So this is a 2.7 meter python, so we would take 2.7 minus 2, standard deviation of 0.3. So we can take this and just plug this into our calculator, right? So let's put our fraction up here, and we're going to say 2.7 minus 2, and we're going to divide that by 0.3, and we end up with a z-score of 2.3 repeating. Okay. The weight of this python that was captured is 30 minus the mean, which is 25, divided by a standard deviation of 5.4. So we go ahead and we'll plug that in to our calculator. So 30 minus 25, and we'll divide that by 5.4, and that's 0.9259, right? So 0.925. So clearly its length is more unusual, okay, because it's higher. The z-score is higher for length. This was length, and this was weight. Okay, so work on the problems we have coming up here on the rest of the page, lesson practice, and we'll see you soon. Peace.